Hello everyone, good morning. This is Sangeeta, Assistant Professor, EC Department, SNS College of Technology, Coimbatore. So today's topic is LC oscillators, that is Hartley oscillator. So let us have a small recap about the previous video. So in the previous video, we discussed about the basics of LC oscillator, how it is working, what are the components used. That is, there are two components used, that is L and that is inductance and C is capacitor, and the frequency is 1 by 2 pi root LC. And with this, let us discuss about LC oscillators. So there are three types of LC oscillators, that is Hartley oscillator, Colpitts oscillator and Clapp oscillator. So the Hartley oscillator uses single capacitor and a tapped inductor, that is two inductors are used, and the frequency depends on the inductor of the coil and the capacitor. The feedback is taken from the top point of the coil. And in Colpitts oscillator, this capacitor is a split, that is two capacitors are used and a single inductor is used. And the feedback is taken from the junction of two capacitors. And it is more stable compared to the Hartley oscillator. And the third one is Clapp oscillator. It is a modified Colpitts oscillator. That is, in the Colpitts oscillator, if we add extra one capacitor, it is called Clapp oscillator. So the added capacitor improving the frequency stability. So let us discuss the Hartley oscillator in detail. So this is the Hartley oscillator circuit. Here the BJT amplifier. So BJT amplifier is used as an BJT transistor is used as an amplifier, and with this the feedback circuit, that is LC circuit is used, and positive feedback is used here. And let us discuss the construction, that is BJT is used as amplifier, and it is a common emitter amplifier, and it is connected in active region. So the base consists of two resistors R1 and R2. It is mainly used to give biasing to the transistor. And in the input side and the output side, there are capacitors, that is coupling capacitors are used. The input side, the capacitor is called CB, and the output side, because it is connected to the base, and the output capacitor is called the CC because it is connected to the collector. These capacitors are used to block the DC components. And in the emitter side, one resistor and one capacitor is connected in parallel with each other, RE and CE. This components are mainly used to produce stable biasing. And RFC, that is radio frequency coil, is connected, and two inductors and one variable capacitor is connected. So let us discuss the operation, that is the tank circuit is produced oscillations because of thermal noise produced in the circuit components. This noise is given as the input of the transistor, that is through the bias, through the base, it is given to the input of the transistor, and it is amplified, the signal is amplified, and again the output of the transistor is again given to the feedback circuit. So here the oscillations are produced. Here the sine wave is produced. So the capacity determines the capacity is determined by the circuit components L and C. So the equation of the Hartley oscillator is F is equal to 1 by 2 pi root of LTC, that is total inductance, into C, because here there are two inductors are used. Here LT is the total cumulative coupled inductance, and L1 and L2 represents the inductance of first and second coil, and M represent mutual inductance, that is LT is equal to L1 plus L2 plus 2M. The M represents mutual inductance. So the mutual inductance is calculated when two windings are considered. And the other circuit is Colpitts oscillator. So the Colpitts oscillator looks like the Hartley oscillator, but the inductors and capacitors are replaced with each other in the tank circuit. So in Hartley oscillator there are two inductors and one capacitor was used, and in Colpitts oscillator two variable capacitor and one inductors are used, and the frequency is f is equal to 1 by 2 pi root of L Ct. Here the capacitor C1 and C2 are connected in series. So the total capacitance Ct is 1 by Ct is equal to 1 by C1 plus 1 by C2. That is, the total capacitance Ct is C1 C2 divided by C1 plus C2. This is the main difference of Colpitts oscillator. And the differences between Hartley and Colpitts oscillators are feedback element, that is here Hartley 2 inductor and 1 capacitor, and in Colpitts oscillator 2 capacitor and 1 inductor is used. And compared to Hartley oscillator, Colpitts gives more stability because the capacitor gives more stability, and the frequency is 1 by 2 pi root LTC is in Hartley oscillator, and F is equal to 1 by 2 pi L into Ct. So coming to the application, it is widely used in RF circuits. And Colpitts oscillator also used in RF oscillators, transmitters, and stable frequency generation. So hope this video will help you to understand the types of LC oscillator, and this is the assessment type. What is the frequency of Hartley oscillator, and what is M in the frequency of Hartley oscillator? Which circuit produces more stable output? Give your answer in the next class. Thank you.